lecture is in segmentation, and first of all we need to see what is the segmentation, and the main goal is to divide or try to separate the significant region that can correspond to either a portion or entirely in the present of the scene. So, for example, if we want, for example, if we want to find, I don't know, we cannot tell what is actually in the figure, but we can represent it as colors. So if we want to separate the red color, the blue color, and the green one, no, there is no green, red, blue, and black. So if we want to separate the different colors, we can use some of the segmentation technique. Or if we want to separate the object and text, or we want to separate the background and the other written information, we can apply some of the algorithm that we will see today. But what is the main information that we need to strive to find? We can try to find information only which present on the segment that we will proceed. So probably if I want to draw a circle, I can start from here. That will be the center of my circle, and I will try to make it bigger. Okay, that won't be the center, but I'm not good. Okay. I can continue drawing, right? That will be a part of the circle that I want to present, or I cut my image in the manner that I cannot take the entire object that I want to proceed. In this time, yes, probably I will be able to segment this part, but I won't be able to reproduce the form itself. Okay? So, if we want to create or segment, really to take the information about something that is on the image, it should be at least completely or 90–80% to be on the image. Because in this position, for example, if I can take the edge and I can use the half transform. Half transform will allow me to draw a circle, and I will draw it. I will find it. But if it's not a circle, for example, it's a part of some another feature, I don't know why, what, or what will be this part, but I won't be able to recreate it because I will not have the information about the form itself. So the segmentation, we can proceed it only if we have, let's say, 90 or 80% on the image that we will have. Why to use segmentation? Probably it's obvious, but sometimes it's not, that the significant impact of the field of the computer vision, which means that we will get the possibility to take the information and probably to proceed it, because we are seeing with our both eyes. We can see, but when we was young, there is somebody who explains us what is this, or what is this, or this. So we can see it, but the algorithm will help us to understand what is important. Is it important the form? Is it important the texture? Is it important the structure of the information? So we can proceed, of course, through the segmentation process. once we have this information, for example, if we know, for example, here in this image, we know the exact position of this feature. In the next one, probably it will be moved down, up, it depends. If we continue, we can track it even out of the image. Probably we will have it here, a small part here is entirely presented at the image. We have his position and we can track it. We can track it even we have a small part of the object, which is on the image. Okay, so we will have the possibility also to edit somehow the form. For example, if it's an ellipse, let's say like that, probably we can, once we have it here, we can segment the information, and for our purpose, if we have those pictures, values of pixels, if we have bigger resolution, that will help us to define the exact position of the edge of the object that we will search on the image. Okay, so probably the information during the process of augmenting the resolution will give us the higher intensity here and not the around positions. So we will be able to precise the localization of the feature that we want to find. Imagine now that you want to track or you want to localize something really precise, but really precise. In that case, yes, we will see the type of segmentation that we can proceed. It will be really important to have the coordinates. And even if the moving object, let's say like that, the image, because to have a video or a real time, you will, that's a sequence of images, okay? So that will move. Imagine that you need to land, or yes, you will get the, for example, the eruption of the sun. I don't know. Is it important for us people? Probably yes. That will give me a headache, for example. But if we localize it, how we can measure the event? That will be a good question, right? But to have the possibility to proceed it, that will be good to segment the object itself. Okay? And what is the most important thing about the segmentation? This is the answer of the question, what is the content of the image and how we can describe it? What are the attributes? What are the features? What are the dimensions? Is the dimension important or the values are important? Is it the size? Is it the color? Is it the texture? How you can describe this? Is it the form? If I would like to make let's say representation, if you ask me, draw this. This is a galaxy. This is also a galaxy. How you will explain it to me? Which is more important here? Try.
You have to discern an object from background. So you have to decide
Okay,
where
here.
the object ends and the background starts.
Okay. If you use this image, probably that will be easy, right? Mm-hmm. Probably. Here, they are stars, right? Mm-hmm. Describe me how I can explain a galaxy. what I need to do to recreate the event with my pencil.
Since we know that stars are present in the picture, we have to discern between the galaxy and the star. For example, say that
What
the
is
galaxy has
Okay.
irregular shape and also
Regular shape.
not irregular.
Okay.
Yeah.
All the stars have a regular shape.
Well, we have to find some other constraint.
Okay. So
For example, size.
okay. So start for the because we will see a lot of segmentation algorithms. You need to start first what you have and try to enumerate them from the most important through the less important. The more important part for the galaxy will be probably, I don't know, the form, to distinguish it from the stars, right? So try to enumerate them, and after that you can follow the other rules that I will give you. Well, left galaxy, right galaxy, I told you that. So the first technique is thresholding. It involves getting a threshold, and we will try to classify each of the pixels if they present or they are part of the foreground, which means the background, or they are part of the object. If we have value from 0 to 255 and there is an algorithm, the first algorithm, the easy algorithm is auto method. So due to the histogram, if you have the histogram, let's say like that, okay, you have your histogram. How to segment it? How you can segment the object from the background? Imagine that the really easy part will be if you have only one object, of course, and you will see it here in your histogram. That will be perfect. So if we set that all the values, from here to here will be the background. All the picture, that is the intensity, and this is the value. Intensity and the value of the picture. Imagine from here to here is your real object. So you will find a threshold, and you will give for the background, for example, zeros, and for the other part you will add ones, which means 0 stands for there is a background, 1 there is an object, and you will receive binary image. But if you have 8-bit image, in this case, you can tell to the algorithm, okay, every part of the histogram, which is between 0 and 150, will get the value of 0 or the value of 1. It depends what background you want. And another one from 151 till the end 254, you will have this information. You will visualize this information, and you will be able to continue working on your algorithm. So you will take only your feature, your object at the image, okay? And you can continue further. The idea is to select which is important and which is not, to try at least. So the first is the thresholding, as I tried to explain you there. This is our original image, but original grayscale image. We have the values from 0 to 255. We found some threshold, and all the values that are behind the threshold are zeros, and all other are white. And now the segmentation mask. Yes, I color it in different color map, but this is the feature that I can see here, and I color it in nice color to be more visible. But you can add your own colors or the real information that you have from your images. Okay, so now can you explain me which is the feature in the image? The most important feature, I mean.
Maybe the accuracy in the center of the galaxy.
Okay, but can you give any geometrical, for example, knowledge? Geometrical information that you can
Yes.
or
There is
search.
there is a jet stream
Okay, the jet stream, okay, but
of matter.
okay. But if you want to represent it as something,
Like this distorted circle.
yes, and it will be a circle,
Yes.
right? Okay, now if you use, for example, half transform, you will find a circle, and that will be more easy without additional noise on the data, and the ratio will be high, right? Okay, so next example is a region base. Now, those are the particular algorithms that will be suitable for some type of data. For another one won't be suitable at all. So, the region-based segmentation is technique which includes clustering. Cluster, you know what is cluster? Yes, everybody? Cluster. Okay, perfect. So we will search for a group of pixels or regions, of course, which will be will have the characteristic as color, texture, or another feature, similarities. And we will try some clustering algorithm. Again, I can give you the codes for clustering, etc. You can try it at home if you want. The first one is Camis. Somebody? Camis? First time?
First time.
First time. I will explain. So this is the baby step, the first try for unsupervised classification, which means that you will apply a machine learning technique which allows you to find some characteristic that probably you cannot find with your naked eyes. Okay? Probably there is something that you cannot find at the moment. Probably. Well, cluster means, let's find where to go. Here. Okay. First of all, of course, we need our image. Okay. At the first position, there is only, let's say, for us, one object, right? But this object, if we are looking further, we can see that it's not only the form, but it's the color also, which can represent our object, okay? So now, if we really look at the picture, we can see that we have yellow color, we have orange, we have red, we have let's say black, and that was 5, right?
Mm-hmm.
And to be sure that we can take all of them, probably there are more. What we can do, of course, that will be experimentally proved. You need to take at least 50 plus 1, which means more 3. and it will give you 8 classes. You will try to classify your image into 8 values, 8 segments, 8 clusters. Okay, so the first one you will give to the algorithm, I need 8 classes. I want 8 classes. And for the first beginning, you doesn't know where the object is. So you will throw it somewhere over the image, okay? After that, what the algorithm will do is will calculate the distance between each data point and the cluster center that you assigned at this point. It's like a seed that will grow around the best points of pixels, position of the pixels that you want to find. And if you have to sit here and you have also data like that, okay, that will be the result. To try to make the differentiation between all of the values. At the beginning, it doesn't know where to put those classes, the centers of the classes. But in the end, the algorithm will give you the best position of the classes according to the self-organization and according to the values that you have in your image. Which means the class 1, cluster 1, you can give to the cluster 1, for example, the value of 1. Or that you can do it automatically, which means if you find all the values in the cluster, you can make the mean value of the values at the cluster. So you will find that it's not 1, but it will be 2, for example. I don't know. The mean value. After that, you will have a mean value for the second class, for the third one, and the fourth one. Okay, and the centers will be recalculated, and you will do it repeatedly until you have your clusters and all the data is somehow proceeded. You need to proceed all of it. And the result after the segmentation, we have, for me, we have very well described forms that we can proceed, and even we have here, we can find the edges of the object, okay? If we have the edge, we can measure more precisely the dimension of the circle that we want to draw around this feature. Okay. So, do you have any particular questions to this algorithm, or I can continue to the next one? Yes.
Yeah, maybe I think I didn't understand it very well. So could you maybe explain it like?
Okay, so you have a lot of values from 0 to 254, 55, sorry. Okay, so you have your, if you want to describe, to segment my skin, now, if you make me a picture, my skin will be really close to the values that you will achieve with my watch. They are really close. But if I add my hand on a white background, that will be difficult task, right? They are also close. But if I put my hand over something which is dark, the segmentation process will give you better results.
Because there is high contrast.
Yes. Okay. So now, imagine that you doesn't know how many part of the object you have. You can try, of course, with some count. You know that I have a skin to segment, I have glasses and clothes. And after that, experimentally, you can augment the number of the classes that you want to segment, to react if you are correct or not. Because at the beginning, when we talked about the features and how you can describe this particular object. But probably, yes, for the code it will be easy to be segmented, but my skin, no. If I put like that, it won't be easy, right? And now imagine if you're doing it by the color itself, the segmentation of this blue and this blue will get the value of 1, for example. It will enter to the class blue.
So the algorithm will see both objects as one.
Yes.
Object.
Yes. The next technique is named watershed algorithm. It's like water, and you will fill the gaps on the data. Let's say like that. If you have the value which is 0, it will be at the bottom, and 255 will be up, right? Okay, so all the values you will start with the water, and you will start to fill the glass. Okay. You will start, and if you find 0, you will have a small quantity of water. If you find 1, you will have more quantity of water, right? And you will have more and more and more and more. Since you find the water where is the edge of the value, then you can segment your object. You will find over the image, you will find all the pixels which have the value of 0. They will be filled. After that, all the values with value 1 will be filled by the water. Okay, and you can continue. Imagine that you have this again the same image. Okay, so now we have our original image, we have the grayscale image, and what we have done. We are trying to pull the water into our image, and the first will be something that you cannot describe it like a real segmentation, right? Because probably your information somewhere here, it's like drain the water. It's to find from the up to the bottom. Okay, you have two possibilities: to fill the glass, or to get out of the water from the glass.
So first we fill the lowest scale level or color level, which is 0, and then we go up in the scale, and
Yes.
as we go up, the area start to decrease until we get to our object.
Once you have your values, you find the area which will be segmented.
Okay.
So you can start with the 0. You will find all the zeros. But it's the intensity itself. If you can, the gap here, if I put my hand over the black spot, black is 0. My hand will be not 255, but let's say 200. Okay, so you will start with the zeros. You will feel it. My hand will be still up. She won't be touched by the water. There is your water. Okay, that will be your first level. After that, you will continue at the water till my hand is covered by the water. You can look at, as I show you at the first presentation, from the color description, that you can look into another dimension. You have X and Y, but you can look at the color in the Z axis. Now you try to find your layer over the Z axis. And you can find it if you add the water to fill this gap. Okay? Is it more clear or?
Yeah, I'm trying to imagine it as like island among the ocean, and as we add more water, so the water start to rise up and cover parts of this island until we get to our desired feature that we are looking for.
Yes, okay, you can, okay, you change the perspective, but that's okay. Okay, it's work also. It's work, okay. So those are the steps. First, we can load the image and convert it to the grayscale. After that, we will apply thresholding to obtain the binary image. We can try some morphological operation to remove the noise. In this case, the noise will be single. There is no such example, but imagine that you have, for example, several pixels over the background. This is a noise, so you need to remove it. Or if you have, for example, some object which is almost in your area, there is like that. Only a really small part is not in your image. In this case, what you can do, you will proceed to morphological opening and after that closing to try to fix this. Yes, the dimension of your image will be smaller, but you can track it at least. In the next image, you can resize this gap that you have at the data at the first image. But it's not a big deal. It will be a big deal if you have a really high resolution and you have around 10% of missing data. Probably then that will be a problem. It's according to literature, of course, not to me. But if you work with, for example, 8-bit image or 32, it's okay. Well, the next one is edge detection, which is the difference between, we can try, of course, to distinguish the objects into an image, and we can apply, for example, canny edge detection, or, of course, another type of segmentation technique. The first one will be canny edge detection. I will show you results for Sobel and Previt. Those are three more important not important, but commonly used edge detection technique. So for both the three of them, you need to load your image and you need to convert it to grayscale. It's obligatory. After that, you can apply the algorithm, Kani, Stovell, etc. So here in this original image, we can apply Kani edge detection, but the result is almost not visible. For you, probably it's black at all. If you go further, you can see that there is some really small edge that is probably there, but really hard to be seen. But for the sorrow and privet, let's look closer. We can segment the, if you look of course closer, there is something. Okay, if you look closer, you can see the edges that are found. Okay, and here for this particular data, probably you can achieve better results with privet edge detection. If you ask me which one is better, normally in the literature, it's really common to be used Kani edge detection, but here in our data it won't work. Okay, even if you change the level, because to apply it you need the deviation, etc., etc. The next.
Is this something that can be found in this image program that we use?
I think yes, and you will do it. The thresholding is there, and I'm 100% sure. Kani edge detection is there also, if I remember correctly. So in the next part, you will do it yourself. If you have a problem with your computer, you can use mine. It's not a problem. Okay. Your type? Your computer, you have
yeah, the battery kind of type.
but you can use mine if you want. Okay, so the next one is contour-based segmentation, or we will try to segment or to identify, to extract boundaries or a contour of the image. And there is one solution. First, of course, we will load our image. After that, we will pass through grayscale. After that, we can apply, for example, some Gaussian blurring. It's on the software. To make it nice, to make it smooth, let's say like that. You will have some noise and you will try to do it like that. Not to remove it, but to make it nice everywhere. After that, you can apply adaptive thresholding to create a boundary image, because here in the first example, you can say a value and use the value to try to segment your image. But that will be a static value that you choose. But imagine that your information changes. So the threshold needs to change also. She needs to be adapted to your data. And that's why I propose you here to apply adaptive thresholding, which will help you to the tracking process. Then you can find some contours, create a mask, and based on that you can segment and add your result. So here, is it clear where are the objects? It's pretty well segmented, right? We can find the segmented object. And here we also try to segment what we have. Okay, but they are values, they are parameters that you need to try. to see for your particular data and to look again into the histogram. And the last one will be machine learning technique. I'm not sure, do you know about neural networks? And the latest one is UNet for semantic segmentation. Yes, no, only one. This is yes, okay. So here, if you want to use this algorithm, I added also this neural network in the code of Python. It won't work. Why? Because I doesn't have enough data to produce some result. Because I told you I need to be learned. The algorithm needs to be learned also. It's probably a common mistake that we can think, okay, I have 10 images. They are a lot for me to proceed it. That will took me, let's say, 1 day. For the algorithm, that can took around not more than 10 seconds. And he will need more different images, because that will be like you need to go to exam. You need enough examples to take your exam. If, for example, you have 3 types, let's say, class 1, class 2, and class 3. You will have 3 different events. You need to be prepared for your exam. During the classes, you obtain 10 images from the first class. I will add here. You will obtain 5 images for the second class, and you will have only 1 image for the third class. What you can do? Of course, you will learn everything that you have, right? And you need to go to the exam. What is the probability to receive, for example, best grade if you obtain an image from the first class? What is the probability?
Oh, it should be pretty high.
Yes, because you receive a lot of, let's say, a lot of images to be prepared. And what is your grade if you have the third class from the event that you saw only once? How you can be sure that the event that you received on the image during the exam is the same one that you saw in the class? It's not possible. So if it's not possible for you, it won't be possible for the machine also. Okay. There is one example which I took from internet because as I said, I doesn't have enough data to give it to you. So here it's a cloud. This is the example of cloud segmentation. Is RGB image and the ground truth and after that model prediction. Ground truth means that somebody tried to find what is the pattern of this particular object. And after that, the machine will try to segment the same pattern as you learned. The machine will try to find the connections in the data that are related to different segmentation techniques that we saw and many more, to try to distinguish in this particular case, the cloud and the another ground, let's say like that. Okay. And yeah, it's based on the entropy, of course, on the data. Every segmentation, almost every segmentation technique is related to the entropy of the data. And why we need the data augmentation? Of course, after the training process and after that on the exam, you will receive some results. And those results will be represented as accuracy. Zero accuracy means fail. 100% accuracy means also fail. Why? Because in the field of computer vision, if you obtain 100% accuracy, that means that you overtrain your model. You can achieve 99.8 not corrupted accuracy. Corrupted and non-corrupted means that you can trust to the result. You doesn't overtrain your model, because if I give you those images and those classes, and you adapt your knowledge only based on one image, if you achieve 100% during at home, let's say like that, you are at home and you have those 16 images, and you try to say, okay, this is class 1, class 2, class 3, you will be the great student at home, but going out at the exam, you will fail. Because you think that you are 100% prepared, but at the exam you will see that probably you will receive around 20%. Probably, I don't know. It depends. This on the example. And how we can find this? Going to the loss, to the error. If during the training process you have the training accuracy and the validation accuracy, if you go to the 100%, normally your error should go down. During the training process, yes, your knowledge becomes higher and higher, and the error becomes smaller. But during the exam, you will have, let's say here, the validation, you can achieve 70%, because during the training process, you achieve 100%. But the error will rise. Which means if you have rising validation accuracy and rising error loss, then you need to go to data augmentation to achieve better results. Do you have any questions?
I have a question about the augmentation.
Yes.
Is it correct if we use the nested augmentation, which I think means
Is it correct to use?
nested augmentation? Something like if we have 10 images, so we can convert them to 100 images by doing these transformation techniques. And
Yes.
then each one of those transformed images, we augment it and produce another 10 images. So we obtain
It's not possible. Mathematically, it's not possible.
Why?
Okay. I'm not really sure about all the augmentation technique, number of the augmentation technique. But let's say that you have 3 images. First, what you can do, the rotation, right? You can proceed 3 rotation. 3 multiplied by 3, 9.
What are the 3 rotations?
Each image will be rotated at 90 degrees.
But can we rotate the image? other numbers between 0 and 90, like by 1, 3, 2, 3.
Okay, that will be 360 degrees.
So we have 360.
3 images multiplied by 360 degrees, that give you how much?
900 numbers.
After that, what you proposing? To do? To flip it, flop it, etc. Okay, we will multiply it by 3. That will give you 0, 3 to 40.
So we will get like maybe thousands of images from just few images.
You cannot, okay, from 3 images, you need to think, are they relevant to your tracking object or not? Can you find really this position, let's say like that, in the nature of your object? Is it sure that you can have a walking man with the head turned at 180 degrees? Is it possible? Probably for 10 seconds if you have some gymnastics. Okay, a minute, for example.
So
And
we
then?
we need to filter out the impossible scenarios.
If possible. If possible. And even with, let's say, 10K images, okay, what you will receive? You will receive a good, let's say, good accuracy. But imagine now that you cannot simulate all the differences. For example, if you want to the software at the phone, if it's based on color segmentation and it's for me, it will work for my skin, or pretty sure closer to the color of my skin. Is it sure that it works on your skin? Or after I'm going on a beach?
Maybe
It's not so sure. So you need to take a more suitable, let's say like that, attributes that they are not so manipulative.
But maybe can we add or subtract certain number, which is like color factor to control the brightness?
Okay, but you will fool yourself a little bit, because you will think that okay, you learn your algorithm in every possible scenario, and that won't be the case. Because in the real world, we're so different, really so different, and the error of your accuracy, the accuracy will be higher, but at what price? Are you sure that your algorithm will work with all the data? Because now, today you will work with local data, tomorrow you will work with another type of data. So are you sure that your algorithm will work with the different data?
Yeah, it will not be generic, but it will be for this particular application only.
Yeah. Okay, so there is the bibliography if you read or find something else. And now we are going to the last tutorial for today. After that we have a coffee break and the last lecture before the end. And you can open, let's see, I will find again up. I will find where is my image J. Okay. So you can load your image. I will take my previous one, the last one that I downloaded. And now what you can do, you can go to, let me check. You can adjust some brightness and the threshold also.
We cannot see the screen.
Off. Sorry. Okay. No. Okay, is image adjust threshold. What you need to do is to go to the grayscale or RGB or another one. So now we are going to let me, probably it's, oh yeah, it's JPEG, so it doesn't work. Open PNG. Okay, so go to transform, translation, color, split channel. So here you can flip flop, etc. Let's see the brightness. You can find the best brightness if you want. You can, let's try the color threshold up. You can try this to see is it working or not for your data. So try to find your threshold. Can you go?
Yeah.
Okay.
So, take it out.
верни резултатите, нали, трябва нещо.
Аз бях намерила около много.
Само да питам от тематиката тук студена. Може да намериш съвсем малко.
Сега ще си
Кой знае как. Ще може.
секунда.
Аз студена.
Ами, явно нещо не се... Това не е ли на мултимедията?
Не.
А? Благодаря.
Моля. Ето тук го слагам.
Добре, мерси.
Моля.
achieve any segmentation.